everybody, this is Miss Bufford, and this is video number 2 over calculating pH in our Acids and Bases Distance Learning Unit. Your learning goals for this video are to be able to define pH and to be able to calculate the pH from the hydrogen ion concentration. So what is pH? pH is a scale used to determine or describe the concentration of hydrogen ions in solution. This tells us how acidic or basic a solution is. The numbers representing each pH value on this scale represent a simplified way to think about our hydrogen ion concentrations. This is a logarithmic scale, meaning that each number represents a tenfold change in concentration. So where do these numbers come from on the pH scale? To answer this question, let's take a look at the 4 cups to the right. Each cup contains exactly 1 mole of hydrogen ions in different volumes. Let's go ahead and calculate the concentrations. So remember, in chemistry, when we calculate concentration, we like to use molarity, which is moles of solute for every liter of solution. And in this case, I'm taking our 1 mole of hydrogen ions and I'm dividing it by the volume of each cup. If we take a look at the molarity volumes, we notice that they tend to get really small, or they begin to get really small. And if we continued to dilute this solution more and more, they would get even smaller. In chemistry, it's really common to deal with concentrations of hydrogen ions that are really small. And so to simplify our numbers and our calculations, we like to write these concentrations in scientific notation. So what I've done here is I've converted these numbers all to numbers in scientific notation. What I'm going to show you next is the pH values that correspond to each one of these cups. I haven't done any special calculations for this. I've just put them up here so that you guys can compare the pH values to the numbers that we've written in scientific notation. I'd like you to pause this video for just a minute and take a look at the numbers written in scientific notation and the numbers in pH values, and see if you notice a pattern. All right, hopefully you were able to notice that the exponent on each one of our concentrations in scientific notation is equal to what our pH value is. We do ignore the minus sign, but the pH value itself is there in the exponent. So what I've done here is I've gone through and I've calculated the hydrogen ion concentration for each value along the pH scale. Then I've taken those values and I've converted them into scientific notation so that you can compare the number from the pH scale to the exponents on each concentration. And if you'll notice, they're all the same. What this is showing us is that pH values that are smaller correspond to higher hydrogen ion concentrations, and pH values that are higher correspond to smaller hydrogen ion concentrations. So more acidic pH numbers are going to be between 0 and 6, then we'll have a neutral pH at 7, and then more basic pH values are going to be between 8 and 14. Sometimes, though, determining your pH can be a little bit trickier. Let's go ahead and take a look at some equations, and then we're going to practice with some examples. So now let's talk about how to calculate pH. We've already said that if the concentration is 1.0 times 10 to the negative x, then the pH is going to be equal to x. However, if the concentration is anything other than 1.0 times 10 to the negative x, then you're going to need to use the equation below. This equation that says pH is equal to the negative log of the hydrogen ion concentration allows us to calculate pH values that are not whole numbers or that fall in between numbers on our pH scale. It's also good to know how to calculate the hydrogen ion concentration if you're given the pH value. So if you're given a pH value that is a whole number, let's say x, then the concentration is going to be equal to 1.0 times 10 to the negative x. However, if the pH value given is a decimal number, then you'll need to use the equation below. This equation, where the hydrogen ion concentration is equal to the antilog of the negative pH value, allows us to determine a concentration if our pH is not a whole number. So let's go ahead and practice some pH calculations. The first formula that we're going to be using is this one up here at the top. pH is equal to the negative log of the hydrogen ion concentration. These square brackets right here in chemistry, anytime you see anything in square brackets, that means we're just talking about the concentration of whatever is in there. And in this case, we're talking about the concentration of hydrogen ions. So what we want to do is we want to use this formula to determine the pH for these calculations down here. So I'm going to start with number 1, and number 1 is giving me a hydrogen ion concentration of 1.0 times 10 to the negative 9th. And if we remembered from the earlier slides in this video, anytime the coefficient on this number or this concentration right here is 1.0, our pH is going to be equal to the exponent on that end of that number here. So in this case, for number 1, we don't need to use the calculator because we can clearly see that our pH is going to be equal to 9. For the rest of these numbers, though, they do not have a coefficient of 1.0, so we're actually going to need to plug those concentrations into this formula up here. So let's go ahead and see what that would look like. For number 2, the hydrogen ion concentration that's given is 2.3 times 10 to the negative 3rd. And I'm going to go ahead and write my equation down here. So pH equals the negative log. And in some parentheses, I'm going to go ahead and insert that concentration. So 2.3 times 10 to the negative 3rd. All right. So you might be looking at this wondering how to put that into the calculator, and what I've done down here is I've tried to provide you guys with a list of buttons that you're going to push. So we're going to enter into our calculator negative log, and then we're going to type in this coefficient right here. So this is where our coefficient would go. And then when we enter this number into scientific notation, or we want to enter it into the calculator using the scientific notation function in your calculator, you want to try to avoid hitting the multiply button and then 10 and then using the little caret. We don't want to do that. So what we want to do is, instead of this times 10 right here, I want it to insert a little E. And it's not just the letter E from the calculator, it's this double E button right here. And so I'm going to hit the second and then the little comma button right here that has the double E above it. And it's going to put a little E inside the calculator, and that E represents that times 10, and whatever comes after that is going to be our exponent. And so we want to enter negative because we always want to have a negative number as our exponent in there, and then that's where we're going to enter our coefficient here, and then we want to make sure to close the parentheses. So let's go ahead and see what that looks like. So for this one right here, I'm going to hit negative. And I want to make sure I'm using the negative button, not the minus button. So negative log 2.3 second E negative 3. And I want to make sure to remember to close those parentheses. The calculator automatically puts the first one in there after the log button. Close the parentheses and hit enter. And this shows me that the pH of this solution is 2.6. And since I only had 2 digits in my coefficient, I'm just going to include 2 digits in my pH. All right? So let's go ahead and try another one. So this hydrogen ion concentration is 4.5 times 10 to the negative 11th. I'm going to go ahead and put that into my equation. pH equals the negative log of 4.5 times 10 to the negative 11. So let's go ahead and calculate this in our calculator. So I'm going to hit negative log 4.5 second E negative 11. I'm going to close my parentheses and hit enter. And that tells me that my pH here is going to be 10.3. And actually, really, I should only have 2 numbers there since I had 2 numbers in my coefficient. So my pH is just 10. Okay. All right, so let's do number 4. Our hydrogen ion concentration is 2.0 times 10 to the negative 2. So I'm going to go ahead and write out my equation, negative log of 2.0 times 10 to the negative 2. And I want to go ahead and plug this into my calculator. So negative log of 2.0 second E negative 2, close my parentheses, and hit enter. And that gives me a pH of 1.7. Let's go ahead and round that to 1.7. All right, so that's how we use this equation right here in our scientific calculator to calculate the pH of a solution when the concentration is something other than 1.0 times 10 to a power. Okay? So now the next equation that we're going to use, we're going to be calculating the hydrogen ion concentration when we're given a pH value. And remember, if this pH value is a whole number, meaning it has no decimal in it, then our concentration is just going to be 1.0 times 10 to whatever that pH was, the power of that pH. But in this case, it doesn't look like that's the case. They're all decimal numbers, so we're going to have to use this equation right here. So I'm given this pH of 7.5 here, and if I was going to plug that into this equation, it would say my hydrogen ion concentration is equal to the anti-log of negative 7.5. And this 10 right here is actually the anti-log function. So when we plug this into our calculator, the first thing we want to do is we want to hit the second button and then log, and you'll see that it gives us that 10 with a space for an exponent after it. And we're going to enter negative, you always want to make sure you put a negative in front of that, 7.5, and hit enter. And this is telling me that my hydrogen ion concentration is 3. We only need two digits in our coefficient, so I'm going to round that to a 2, times 10. So remember that little e right there means times 10, and whatever comes after the 10 is our exponent, times to the negative 8th power. All right, so there's our hydrogen ion concentration for a solution with a pH of 7.5. All right, let's do this next one. So our hydrogen ion concentration is going to be equal to the anti-log of negative 1.2. So I'm going to hit second log negative 1.2, hit enter. And in this case, it's not giving me my concentration in scientific notation because it's kind of a high concentration. And so I'm going to go ahead, I'm just going to write it out like this, 1.0, and I need two significant figures, 6.3. And it's okay in this case to leave it like this, or if you want, you can convert it to scientific notation. So let's go ahead and do that. So then we end up with 6.3 times 10 to the negative 2. All right. So there's our final answer right there. The next one, number 3, our pH is equal to 12.5. So my hydrogen ion concentration is equal to the anti-log of negative 12.5. All right, so I'm going to hit second log negative 12.5 and hit enter. And that's going to give me a hydrogen ion concentration. I need 3 sig figs here, so 3.16 times 10 to the negative 13. All right. And then my last one right here, my pH of 3.3. So hydrogen ion concentration is equal to the anti-log of negative 3.3. So let's plug that into our calculator. Second log negative 3.3, and that gives us a hydrogen ion concentration of 5.0 times 10 to the negative 4th. And there's my final answer for this last one. Go ahead and circle all these. I hope this video was helpful. If you have any questions, don't forget that my office hours are between 10 and 11 Monday through Friday. You're welcome to contact me on It's Learning, or you're welcome to send me an email anytime and I'll get back with you as soon as I can.